We've recently hit over 50,000 subscribers on my YouTube channel, and I would like to thank you all so much for all of the support. In this video, I would like to go through some of my earlier PCB designs when I first started PCB designing about 2 or 3 years ago, and see how my PCB designs have improved and changed, and what kind of mistakes I made personally when I first started with PCB design. As usual, thank you so much for Altium for sponsoring this video. You can get a free trial of Altium Designer if you go to altium.com/yt/Phil's Lab. So you get a free trial, and you also get 30% off your first Altium Designer purchase. You can see a lot of my videos on my YouTube channel that will cover Altium Designer, but of course I will continue with the KiCad videos as well. On the topic of KiCad, I am still heavily working on the PCB design course. It's taken me quite a bit longer than expected. I will leave a link to the Google Docs form survey so you can actually enroll yourself for the PCB design course, at least register your email and your interest. Just tell me what you think about the course and what you'd like to see in it. It will be a mixed signal PCB design course as I previously discussed, and I hope to release it in the next few months. I must say in advance that I haven't really planned this video, and I'm just going through old project files to see what I've been making. So this is the first PCB I believe I ever made, and that was in KiCad, and it was a shield for the Arduino Duo. Essentially I was working on some sort of drone and the flight control system for it, and I was just working with Arduino because that's what I was familiar with, and I wanted to make some sort of sensor adapter board. As you can see, also KiCad 6 has been released, so I need to play around with that a bit more. So let's have a look at the schematic first of all. And you can see this was the schematic, kind of organized-ish, but not really. So I could have put these on separate schematic pages, and I could have organized it a bit better, made it easier to read. For example, the text IMU could be a bounding box around it and so forth. Other things that I don't like, at least from my standpoint now, is that decoupling capacitors should go to their relevant pins and not be free floating. Also, I like pointing my positive voltages up and my grounds down, and here I've pointed them kind of to the side, which isn't that great. Also, I haven't labeled all the nets, it seemed. I've labeled the main ones, for example I2C, but for example there's reg out pin. If I go to the PCB editor, this will then basically not have a net name, it'll be net C8, something like that. The same for this LED. I can really see the current limiting resistor for this LED is far too small. So 3.3 volts, 100 ohms is going to give me, I don't know, something about 10 milliamps, maybe a bit more. And that's very bright, especially for sort of a debug LED. So it should probably be in the order of a kilo ohm, or if not more. Then I have some headers here. At least I have power and ground on the headers. I think that's okay for a first PCB. I've got some various ICs here. So let me see. So this is actually the Arduino Duo footprint. I've got pull-out resistors. 1.6 kilo ohms might be a bit of a weird choice, and I'm not sure if the Arduino Duo already has them on it. So I'll probably go with the higher pull-out resistors these days. Then I have this PWM driver, and I'm sure the Arduino Duo can drive PWM on its own anyway, so I don't know why I added this chip. Again, this doesn't look very nice. You have to turn your head sideways to kind of see it. What else do we have? We have a GPS receiver. So I think this is probably where things really went wrong. I believe I just copied things from the datasheet for this one, but it's very hard to see, what connects to what. Why is this kind of LC filter on the UART lines? That looks a bit strange to me. Antenna matching, I'm not sure if there's anything. This would have to be a passive antenna since there's no bias D circuitry. And all these symbols and schematic symbols aren't very nice to look at, and it's kind of hard to see what's going on, so that's not great. Keep in mind this is for first PCB. Then we have the barometer over here, which connects to the I2C bus. Let's see, I2C0. There we go. And I2C0 for some reason doesn't have pull-ups on it. Maybe Arduino Duo only has pull-ups on I2C0 and not on I2C1. That could be, but I'm not sure. I'm not too familiar with it anymore. But again, the capacitor's kind of floating away somewhere. And here I've also opted to connect them together like this, whereas up here I have them separately. I don't really know why. So I can do much neater, of course, my schematics, and that's something you should do. So basically I'm just going through critiquing my first PCB designs. So we can actually go over to the PCB editor to see what the shield looks like. So you can see here, I believe it's a 2-layer board. I hope I did connect that up at the end of the day. Let's have a look. Maybe I forgot to connect that, but let's see. Let's go to the 3D viewer just to get a bit of a better view. Okay, so this is what the shield would look like. I would attach some pins and that'll slot into the Arduino Duo board. So the first thing I noticed, I haven't got all of my 3D models, and that is something I typically like to do these days because it helps you see mechanical constraints, seeing if the pads match the footprint, at least if the 3D model is correct. What I first see as well is that I have all of these, SMD components, but then I use these huge through-hole LEDs, and I'm not entirely sure why. One thing I can also see is like the capacitor placements. They're pretty far away from the IC pins or the relevant IC pins themselves. Then I have these random GPIO headers, which I don't really like anymore because they're easy to attach to, but also very easy to fall off. So that's not great. What else can I see in the instant here? Let's have a look at the antenna connection. That just jumps out. Basically, this UFL connector, what it should be, these large pads are ground pads, and these should be tied directly with very short traces to a ground plane below. Instead, in my first PCB, I've opted to just, draw really thin ground traces right into the RF receiver. And let me tell you, this receiver part did not work, and for good reason, looking at back now. I also have holes in silkscreen. That's not great. The silkscreen, other than that, is, okay-ish. What I also noticed in this first PCB design, well, this isn't connected, first of all. And that is probably because I didn't use a ground plane. So I don't think I have a ground plane, top or bottom, which is very bad practice. And I'm just running signals connecting my 3.3 volts and also just these little traces connecting ground. So very much this kind of breadboard type of thinking where you have point-to-point-to-point ground connections rather than a solid ground plane. Okay, so that was the first PCB I believe I ever made. That was 2019, maybe a bit earlier. So let's have a look what else I can find. Okay, so I believe a couple of weeks later, or maybe a month or so, I redid this Arduino shield. I believe this is even version 3. So let's see if I improved my designs even a tiny bit. So here we are on the schematic again, and you can see it's quite a bit neater than it was before. So I have larger text, I have segmented it, well, nicer, and I've added some peripherals. So let's just go through quickly. You can see I've increased the value of the current limiting resistors, as I said previously, because they were far too low and it was a really bright light when I probably tested it. I've added an SD card connected via SPI. Again, ground should be pointing down and not to the side. 3.3 volt, I could rotate this label. The crystal, the footprint or the schematic symbol isn't great because the crystal pins, there's one on the left here and there's one on the right. They should be next to each other. And then I can simply connect this crystal up there. I'm not entirely sure if these load capacitors are correct. I guess I just took this. You can't really take it from the datasheet because all the crystals are different. I also don't like the labeling or the schematic designators. So I don't know why I called it CIMU1, CIMU2, and so forth. Yeah, it kind of makes sense, but it's better to do it with just, C and then a number. Okay, what else do we have with an EEPROM? I could have just uses one ground and connect them all together for the sake of clarity, instead of using 3 grounds. What else do we have? So sort of inverter. And it's always hard to see that, for example, this capacitor belongs to this IC. Let's see what else we have. The GPS. I believe I used a kind of complete GPS solution this time. I'm not entirely sure. So let's see. I believe everything was just on one solder PCB. Okay, I assume that's all taken from the datasheet. And we have the usual stuff again. So let's go with the PCB design and see if that's changed. So the first thing we can see now is that we have some sort of plane. But it looks like it's just on the top layer. It's just on the top layer and it's a ground plane directly on the top layer. So slight choice, very strange choice. I don't know why I did that. I have changed from through-hole LEDs to SMD LEDs, so that's a bit better. I can't see problems. Okay, here we go. Another hole in the silkscreen isn't great. And also this ground plane isn't attached to a ground plane on the other side. So there's a lot of these patches of ground that probably will act as antennas and resonate, so that really isn't great. I'm not sure what else I have on here. I've moved the capacitors a bit closer to the pins. I could make these traces thicker. I don't like the ground connections, and this doesn't look finished either. Maybe this is an old version that wasn't saved. So a tiny improvement given, I know, a couple of weeks of learning a bit more about PCB design. So let's see what else we can find. So here I found something similar. I believe this was done a couple of weeks after these Arduino shields, and I kind of moved to Teensy because they were quite a lot more powerful. So let's have a look at the 3D view of what this board looks like. It's always weird looking back at your old PCB designs, seeing what you could have done better. So I'm wondering what in 3 years I'll think about my PCB designs now, how bad or good they are. First thing I notice as well, at least I have planes at the top and bottom. And just see if they're ground or not. I think they're ground, but I'm not sure, but let's have a look. But what I don't like is, I think these are the standard KiCad hand soldering footprints, which is fair enough because I was hand soldering them at the time. They have huge pads, which is a bit grim and doesn't look that nice. Silkscreen, again, another hole in the silkscreen, not great. It looks a bit neater, at least I have some sort of mounting holes. I've got rounded edges. Component placement is a bit better. Like the capacitor's a bit closer. I have wider traces for power, thinner traces for signals. So it is a bit better. I have most of the 3D models as well, so that isn't that bad. So you can see this is improving. This might be after a month or two of PCB design. So it is getting there. So here's another interesting one. I think this was maybe half a year after I started with PCB design. Still pretty awful by the looks of it. So I have a bit more complicated schematics. So this is the first time I believe I tried playing around with STM32 microcontrollers. So it'll be interesting to see if I got anything right at all. So I have the boot 0 pin that's at least pulled low, and I can pull that high with a jumper. I have most of my nets labeled, even though not great. I think the USB connections, I basically only need the differential pair, which is over here. Serial wire debug. Heavy filtering on the VDDA, that's not great. I have a 47 microhenry plus a 10 ohm resistor and a huge capacitor filtering for my VDDA, so that's not great. So that's, I don't know if that's would have worked. Capacitors seem to be there. I've increased my current limiting resistance for the LEDs again. I have not told people what the colors of these LEDs are, so that's not great. And this ID is kind of hidden behind these pins. There's obtruded component designators. That is pretty rough. So what else do we have? Decoupling capacitors. That's a good sign, even though they could be connected to the relevant pins. We have a current sensor, it seems, and some sort of buck converter. And this is a pretty chunky one. I believe these LM2678s are really high current ones, and I believe I was doing that because I wanted to feed some servos from the battery power. Sensor resistor, I assume I just took this all from the datasheet. USB, I believe, I don't know what chip this is. SM32F4, I don't believe, I think you definitely don't need these termination resistors. So that's a bit strange. What else do we have? Another USB debug, so basically an FT232, so an FTDI chip, which is UART to USB. Don't know why I need that, because I can just do everything, via that USB. So that's a bit strange. Again, PWM driver. I could have just used the SM32F4 and a couple of sensors. Okay, so at least the schematics are getting a bit more complicated. They don't necessarily look nicer, but I don't know if that's a good thing or not. So let's move it to the PCB. So I believe this was a 4-layer PCB. Now if we go through it in KiCad, I have not done something very well. I've done a 4-layer PCB, and I think this was my first 4-layer PCB ever. So let's just wait until this renders. Again, I am missing 3D models. It looks kind of okay, like decoupling capacitor placement could be a lot better. There's loads of thin traces here, bad ground connections, they're too far away from the pads. It's not great. Also, no clearance next to all these traces. I could have spread them out much better. Also, I filled copper top and bottom, I believe, and I hope I've stitched that together. Also, I don't like the clearance between plane and traces. Thermal reliefs I don't really do anymore for SMD components, only for through-hole. I have this SMA connector here, and that is just going... This feed bias, this is supposed to be some sort of bias network for an active antenna, I believe. So it has an AC cap and either inductor or resistor, which isn't filtered, essentially, in this circuit, so that's not great. Biasing this active antenna, and that doesn't look very right. I have got one path, a stub going off here, and this just going in here. Basically, the resistor should be turned in the path of this one single trace to apply the bias. Otherwise I have this weird stub here, so I'm pretty sure that wouldn't have worked. This Wi-Fi or whatever module this is, radio module, probably needs clearance underneath the antenna, so this will not have worked. It's also very close to the USB. That is not great. Again, holes in the silkscreen. Apparently I love doing that. I probably could have done everything with single-sided assembly, so I don't know why I opted for two-sided. I think I tried to assemble this myself. Yeah, weird choice for headers and connectors, so overall not great. But I think the biggest sin I committed is that I didn't leave the internal planes as either ground or power. I misused them and also did loads of traces with really bad clearance. So this is not great. I should have just done, both internal ground planes and so forth. Well, let's see. Let's move on. Okay, so I think actually the next PCB after this was the Hades flight control system. This black board I've also featured on my channel, and that was shortly after the previous PCB, and I think I studied up quite a lot about PCB design, so let's hope I'm not talking nonsense here. Okay, so for KiCad 6, let's see. Okay, so the first thing I see is at least I've segmented things into different schematic pages. So I have one with the flight control computer, I have one with the peripherals, navigation computer, more peripherals, connectors and so forth. So that already looks much better than before. I have drawn my schematic in a way that I can read it a bit better. So when I've come back to this after 2 years or however long it's been, I can read it just a bit better. I've telling people what type of capacitors they are, what sizes, what ratings they should be. I've given proper net names, ground is pointing down and so forth, tolerances of the resistor. So this is surprisingly much better, given that as a jump from the previous PCB you saw. So that's, in my eyes, pretty decent already. So this is a buck converter. I don't like the way I've done the connections here. So the output filter, that should just go straight into the buck converter. We have another regulator, another 3.3 volts. So okay, so the first one's 5 volts, and that feeds into a linear regulator at 3.3 volts. Okay, we have a current sensor, so that looks a bit better. I can also navigate in KiCad by using the button up here. So because this is an older project, some of the footprints haven't loaded properly. So again, USB, I have series termination resistors, and I don't believe you need that for most STM32 MCUs. I have serial wire debug. It's a shame I didn't point ground down. I could have added ESD protection, filtering, and so forth. Let's have a look. Peripherals. It's getting a bit better, I think, at this point. And this is maybe a year after my first PCB. I'm not entirely sure anymore. Flight control computer. Okay, so this was an STM32H7, so quite a beefy one. I forgot to add the actual part number, so I think it's a VIT6. I've given references to application notes, which I use, so if you want to program this board via UART to USB, I'm saying what peripherals I've enabled for what functions, so that's much better than before. I'm also telling what internal pull-ups things have, my crystal oscillator calculations, so that is certainly a lot better than before. Let's have a look what the PCB design looks like. So I believe this was a 4-layer PCB. Let's have a look. I still need to get used to KiCad 6, but let's have a look at the 3D model first of all. Wait till the components load. And here we go. And finally, I believe I have all 3D models in there. So I even have the connectors, SMA connectors. It's a dual assembly board, and already this looks so much neater than what I did before. So I think this is kind of my first somewhat proper PCB. I've tried to take a bit of care with connector placement, component placement. I've used smaller components, better footprints. This is 0402, I believe, or 0603, I'm not entirely sure. Better connections, short traces into the decoupling capacitors, fat traces to ground, digging down to a ground plane. And I hope I haven't done holes where there is silkscreen. So far, I can't see anything. I've marked things properly. I've given axes for the IMUs, proper designation of what these connectors are for. And this bias T looks still not great, to be honest. Like this resistor should be in line here. This pad should be in line with this trace. So it's a bit better, still not great. The buck converter layout. I think this is the main buck IC. This is the inductor here. So this could have been made much tighter. I could use a smaller inductor probably. So that isn't great, this buck converter layout. But I think it's one of my first attempts at a buck converter layout. Another problem is this GPS receiver is pretty close to this inductor. Not great. And also close to this crystal, apparently. I don't know why I opted to use, well, I do know why I opted to use two MCUs. I tried to, distribute loads between this one, but the STM32H7 is such a powerful MCU that you probably don't need it. I also see trace clearance is awful. Like, this is the absolute minimum trace clearance. So you can have crosstalk, you can have noise, God knows what. So that's not great. Physical buttons, don't really like. This is supposed to be some sort of flight computer. Also I have 4 USBs, which looking back is mental. Because I've used 2 essentially for programming and 2 for debugging for each of these MCUs. I could have just used 1 for each. First attempt at popping a little logo on. At least I've labeled my pins of the connectors. I think that's good practice. What again I don't like what I've done is that I have poured copper on all layers, but I've also, in the internal 2 layers, again I've routed traces, and that's just something you definitely should not do, only if it's, only if you really can't do it otherwise, and then probably you should go to a higher layer count. But okay, this seems to be the first proper PCB-ish. Incidentally, I actually found a picture of what this PCB looked like when it was assembled. So this is the first PCB I also had fully assembled by a fab house, and it came back, and for once I believe everything pretty much worked, even the GPS receiver given the close proximity. But both of these MCUs worked, all the sensors worked, and I've published everything in Git repo. It's a good first try of STM32 microcontrollers, but there's definitely a lot you can improve. So fast forward about 2-ish years, end of 2021, and just see how my PCB designs have improved, how my schematics improved. This is a project I'm currently working on. It's an exciting zinc-based FPGA board, just a little breakout board, system on module, and just to see how the schematics have improved. So for example, this quad buck converter, I have everything, I make my own symbols, I make my own schematic symbols, footprints and so forth, and make sure I arrange my pins in a sensible way. Okay, so I have my decoupling capacitors here, I have my voltages that are positive going up, my grounds going down, I give information what certain pins do, what they need to be set to. For example, these output sections of all these buck converters are clearly labeled, all the net names are labeled, all the values are right, and so forth. This is quite an improvement over what I showed you previously. Also the fact that as you gain more and more experience, and the thing is it takes time and practice and getting things right and wrong, you can get more complicated designs. So routing DDR3 memory, or even just getting the decoupling right for that, is something that just takes some time to learn, and something you will move on to. And that includes various design choices, for example ESD protection, filtering via common mode chokes, when to use termination resistors and so on. So all these things you improve on as you progress with your PCB designs, hardware designs, and keep trying to challenge yourself. For example, even though this board here, this little Brain++, is not very complicated, it just contains a microcontroller and some sensors, peripherals and so forth, you can see that the routing and the layout has just improved by quite a margin. Also just the fact of how I've created the schematics, just far easier to read than anything you've seen from the stuff when I just started with PCB design. So a fairly natural progression. So things, for example, routing with power puddles, these copper pawls just to connect our power components, thicker traces for power traces, matched length differential pairs, placing ESD protection in line and not as some sort of stub, proper grounding by using internal power planes, not using the power planes or the ground planes for routing, and just using the top and bottom and routing power with thick traces, signals with thin traces. All these kind of things I've kind of progressed on. So it's nice to look back and see, I've made these improvements, and hopefully in the next 2 years, I will look back at this design and say, okay, I could have improved on this by quite a lot. So yeah, so basically these kind of how my designs have improved. Also when it comes to higher layer count, kind of 6 or 8 layer boards, for example, this electronic speed controller module and so forth. So yeah. So thank you very much for watching. Please, if you feel like it, leave a like and subscribe, and I look forward to the next year with many videos to come. And please, if you could, leave some comments in the below under the YouTube video and tell me what you'd like to see in future videos. Thanks again, and I look forward to seeing you in the next year.